An unexpected revelation from the James Webb Space Telescope has captivated the scientific community. The detection of urban light signals originating from space, situated a staggering 7 billion kilometers away from Earth, has raised new possibilities in the search for extraterrestrial life. By concentrating on Proxima Centauri b, the closest exoplanet to Earth, the telescope uncovered unusual bright lights radiating from its surface. What could be causing these mysterious lights on Proxima Centauri b? Could they signal the presence of life beyond our planet? For years, humanity has yearned and searched for signs of life in the vast expanse of space. Any indication suggesting such a possibility has been met with great excitement. Recently, the scientific community was shocked when the James Webb Space Telescope presented compelling evidence of life forms in the cosmos. While exploring the universe and transmitting vital data back to Earth, the telescope detected strange urban lights coming from Proxima Centauri b, an exoplanet situated in a distant star system. These lights, as their name suggests, are the first of their kind ever to be seen in space, appearing to illuminate what seems to be a far-off city. The concept of an alien civilization existing in the star system has left scientists puzzled, filling them with a sense of awe and wonder. They are amazed by the possibility that this could be the discovery they have been hoping for. If confirmed, this would mean that intelligent life forms have developed societies far beyond our comprehension, both here and in space, and we are just beginning to uncover them. As scientists analyze the lights from a distance of 7 billion kilometers, NASA engineers wonder how long these lights may have been glowing in space, waiting for humankind to develop the necessary technology to detect them. David Kipping, an astronomer from Columbia University, describes Proxima Centauri b, the exoplanet where these urban lights have been observed, as a celestial body with unusual heat patterns that differ from those seen on other planets. While typical rocky planets absorb sunlight and release infrared radiation, Proxima Centauri b displays markedly different behavior when interacting with its star Proxima Centauri. This distinct behavior has made it an ideal subject for the James Webb Space Telescope, whose advanced infrared capabilities are highly sensitive. Proxima Centauri b's thermal signature will be key in uncovering the secrets of its atmosphere. Taking advantage of the telescope's state-of-the-art infrared imaging, scientists plan to study the planet's atmospheric mysteries and assess whether it might be capable of supporting life. The James Webb Space Telescope, with its exceptional infrared sensitivity, is ideally suited for probing Proxima Centauri b, as it can detect even the faintest light signals in the cosmic darkness. Its narrow frequency band, 1,000 times narrower than starlight, allows it to detect artificial illumination, making it an invaluable tool in the search for extraterrestrial life. Proxima Centauri b's intriguing connection between its surface features and interactions with its host star further enriches its appeal. The daytime side of the planet is covered with solar panels that capture energy from its star, while its night side experiences extremely cold temperatures. This contrast in temperatures, due to the planet's atmospheric composition, offers an intriguing area of study for astronomers. Furthermore, the telescope can effectively measure the planet's thermal emissions, providing critical data on its atmospheric properties. The JWST's orbit, which is in sync with Proxima Centauri b, ensures comprehensive observations of both its daylight and nighttime cycles. These observations span 11.2 Earth days, giving scientists a unique opportunity to study the exoplanet's full rotation. The next major step will involve analyzing the atmospheric chemistry of Proxima Centauri b to determine whether it could support life. This will focus on gases such as oxygen, methane, and water vapor, which are deemed necessary indicators of habitability. If these gases can be detected in the atmosphere, it could imply that the planet has conditions favorable to life. However, this task is exceptionally challenging, as it requires capturing and analyzing the light passing through the planet's atmosphere. Although the James Webb Space Telescope is highly capable of studying planetary atmospheres, it faces limitations, especially in terms of detecting oxygen, a crucial indicator of life. Still, the telescope will search for other elements like ozone, which could offer further clues about the planet's potential for habitability. It's important to note that the JWST cannot explore all potential habitable worlds, as its capabilities are restricted to observing only the closest exoplanets. For a more in-depth investigation, astronomers are relying on ground-based observatories, such as the Extremely Large Telescope (ELT), which is expected to begin operations in 2028. This facility will enable even deeper exploration of distant exoplanets. Scientists eagerly anticipate the launch of future space telescopes, which will expand our knowledge of exoplanet exploration. While the JWST has its limitations, it remains an essential tool for unraveling the mysteries of distant planets. Future missions will focus on overcoming obstacles, such as reducing the glare of host stars, to better study the light reflections from exoplanets themselves. This process will help researchers differentiate between gases produced by life forms and those generated by geological processes. Despite these challenges, scientific progress continues to advance, and the James Webb Space Telescope is a pivotal step forward in our comprehension of far-off worlds and the broader universe. After decades of research and exhaustive searches for life across the cosmos, the question still lingers. Are we truly alone in the universe? The search for life beyond Earth is one of the most profound endeavors in modern science. With each new significant discovery, excitement grows, even as the mystery deepens. Proxima Centauri B's enigmatic lights, captured by the James Webb Space Telescope, have added a thrilling new layer to this ongoing search. If these lights are indeed artificial, it could change our understanding of life in the universe forever. The implications of such a discovery are monumental, suggesting that life, and potentially even intelligent civilizations, might be far more common than previously believed. The possibility that a technologically advanced civilization could exist millions of light-years away challenges everything we know about space, time, and the development of life. While it's still early in the investigation, the urban light signals observed on Proxima Centauri b are an extraordinary hint that we might not be alone. The proximity of Proxima Centauri b, located just over 4 light-years away from Earth, makes it a prime candidate for further study. The telescope's ability to detect subtle signs of artificial light so far from home is a testament to the progress we have made in space observations. Researchers analyzing the data from the James Webb Space Telescope will focus not only on urban lights but also on other key atmospheric indicators that could point to the presence of life. These include a detailed examination of the planet's temperature variations, which can offer important clues about its atmospheric composition and whether it could sustain life. As more data is gathered, researchers will improve models and hypotheses, getting closer to answering one of humanity's oldest questions. Are we alone in the universe? Meanwhile, space agencies like NASA and other global partners are ramping up efforts to develop even more sophisticated telescopes and observation technologies. The next wave of telescopes, like the Extremely Large Telescope (ELT), will offer unprecedented resolution and the ability to study distant exoplanets in much greater detail. This will provide invaluable insight into the conditions on planets like Proxima Centauri b and others that may harbor the potential for life. While the James Webb Space Telescope has already made history with its discoveries, its journey has only just begun. The telescope's incredible capabilities will allow for ongoing exploration of distant worlds, providing a deeper understanding of how planets form, evolve, and potentially develop the conditions necessary for life. With each new discovery, we come closer to answering questions that have fascinated humans for centuries. In addition to studying the lights from Proxima Centauri b, future missions will focus on gathering even more data about the planet's atmospheric composition. Researchers are particularly intrigued by the presence of key gases such as oxygen, methane, and carbon dioxide, which are often associated with biological processes. If detected, these gases could serve as biomarkers, suggesting that life may indeed exist on this far-off exoplanet. However, detecting these gases is no simple task. The challenge lies in the need to isolate the faint signatures of gases from the overwhelming light of their host star. The next generation of space telescopes will likely be able to address this challenge, enabling more accurate measurements of the chemical makeup of distant planets' atmospheres. This advancement will be essential in determining whether planets like Proxima Centauri b have the right conditions for life to thrive. As astronomers and researchers continue to explore these possibilities, they are also keenly aware of the limitations of current technology. The James Webb Space Telescope is a revolutionary tool, but it cannot explore every exoplanet, and its observational capacity is limited to certain types of stars and planets. To broaden our understanding, ground-based observatories will play a critical role in complementing the telescope's work, offering new ways to analyze distant worlds in greater depth. The future of space exploration is incredibly exciting. With advanced instruments like the JWST, the ELT, and other upcoming technologies, we are on the brink of answering some of humanity's most profound questions. Could there be other worlds out there with civilizations just waiting to be discovered? Or are we, in fact, the only sentient beings in the vast universe? Only time and continued research will tell. As we venture deeper into the unknown, each breakthrough brings us one step closer to understanding the full scope of the universe and our place within it. The recently discovered information from the James Webb Space Telescope offers hope that we may not be as isolated as once thought. The discovery of urban-like lights on Proxima Centauri b has provided a tantalizing glimpse into the possibility that intelligent life might exist beyond Earth, challenging the long-held notion that we are alone in the universe. The excitement surrounding these urban light signals is grounded not only in their unusual nature, but also in the sheer implications of such a discovery. The idea that a distant world could host a thriving, advanced civilization raises profound questions. Might we be witnessing an alien society that has managed to thrive in ways similar to humanity's development? If these lights truly originate from an intelligent source, it could signify the start of a new era in our exploration of the cosmos. At this stage, the evidence is still preliminary, and scientists are cautious in their interpretation. However, the fact that these lights are being detected from such a distant exoplanet is a breakthrough in itself. It signals that our technology is advancing to a point where we can detect even the faintest of signals from alien worlds. The James Webb Space Telescope's ability to capture such faint light emissions and investigate their origins is a testament to the progress we've made in space exploration. Looking ahead, scientists will continue to monitor Proxima Centauri b using every tool at their disposal to gather additional information. One of the most critical next steps in the investigation will be to conduct detailed studies of its atmosphere, focusing on the composition of gases such as oxygen, carbon dioxide, and methane. These gases are often associated with biological processes on Earth, so their presence in the atmosphere of an exoplanet could provide strong evidence of life. The study of exoplanet atmospheres is still in its early stages, and it is a complex and highly technical endeavor. The challenge lies in isolating the faint light passing through the planet's atmosphere from the overwhelming brightness of its host star. As astronomers refine their techniques and develop new instruments, the hope is that they will be able to detect even more subtle signs of life or habitability on distant worlds. The James Webb Space Telescope is well suited for this task, thanks to its advanced infrared capabilities. By focusing on the infrared spectrum, the telescope can detect heat emissions and light signals that are invisible to other telescopes. This sensitivity allows it to study the chemical composition of exoplanet atmospheres with greater precision, providing new insights into the potential for life beyond Earth. However, as powerful as the James Webb Space Telescope is, its capabilities are still limited in certain areas. For example, detecting oxygen, a key indicator of life, remains a challenge. Oxygen is a gas that reacts and does not remain in the environment without a constant replenishment source, typically from biological activity. While the JWST can detect other gases like carbon dioxide and water vapor, its ability to detect oxygen is limited by its resolution and sensitivity. Nevertheless, the search for life will continue through multiple avenues, with additional observatories and future space missions playing an important role. In addition to the JWST, other observatories, such as the Extremely Large Telescope (ELT), are expected to provide complementary data. The ELT, set to begin operations in the near future, will offer a much larger aperture and improved resolution, allowing astronomers to study distant exoplanets in unprecedented detail. With the combined efforts of ground-based and space-based observatories, scientists will be able to build a more complete picture of the conditions on planets like Proxima Centauri b.